The lubricating oil inside the compressor circulating is in contact with the pistons it lubricates, which compress the air we use. This mechanism creates vapors and aerosols in the air and leads to the pollution that will inevitably reach the patient. It is essential to save patients and keep the system perfectly functioning. Using oil-free compressors, you can guarantee efficiency and safety. In the air compressor market, you will encounter the phrases Class 0 and technically oil-free, both used to identify how clean the air is after compression. Compressed air has its own set of ISO standards, depending on the maximum air purity. Compressor can be classified from ISO class 0 to 5, the best of which is Class 0. Class 0 oil-free compressors can guarantee 100% oil-free air. These compressors are much safer for sensitive application and are the cleanest choice because no contamination will reach the patient. While technically oil-free compressors have a high probability of contamination because they are lubricated compressors that include oil removal filters. These compressors are classified as ISO class 1. The conventional piston compressor has a crankshaft, connecting rod and piston, cylinder and cylinder head. At the top of the cylinder, the head contains the inlet and outlet valves. Both are simply thin membranes, one mounted under the valve plate and the other above it. Moving downwards, the piston creates a vacuum above it, and this allows the outside air at atmospheric pressure to open the inlet valve and fill the area above the piston. As the piston moves upwards, the air above it is compressed and it keeps the inlet valve closed and pushes the exhaust valve open. The air moves from the exhaust port to the tank. With each stroke, more air enters the tank and the pressure increases. The oil-free piston compressor does not inject oil into the compressor chamber, as it does not contain oil but has Teflon sealing rings that do not need lubricant. An air dryer is an equipment used to dehumidify compressed air to reduce or significantly eliminate moisture present in the airflow, to preserve all those instruments that use such air and that are at risk of significant deterioration caused by the infiltration of condensate fluid, such as dentist's turbine, or could block a productive cycle, for example, a cycle of sandblasting of a laboratory. Atmospheric air typically contains a percentage of water vapor that can create various problems in the equipment and adversely affect the quality of the final products. Vapors in the airflow can condense in the compressed air system and cause corrosion, fouling, and clogged valves. The presence of moisture in process systems reduces lubrication, leading to the wear of moving mechanical parts, such as turbines. Condensed vapors can cause control lines to freeze, and this can interfere with the operation of the equipment. Moisture in compressed air systems can cause measurement equipment to provide inaccurate readings that could lead to unplanned stoppages. Refrigerated air dryers are a common option for eliminating water vapors, aerosols, and mist in compressed air systems. They can get dew points suitable for most applications and are simple to install and maintain. The compressed air entering the unit is first cooled in an air-to-air heat exchanger. The outgoing cooled air pre-cools the incoming hot air, condensing the moisture present in liquid water that is discharged out of the system. The pre-cooled air then enters an air coolant heat exchanger that cools it using a liquid coolant. The moisture condenses in liquid form and is drained out of the system. This type of dryer has the advantage of not requiring periodic maintenance. You should be aware that the refrigerated air dryer works only at temperatures above 3 degrees. Under this value, the condensation will freeze and block the system. This type of air dryer uses 1 or 2 towers, better 2, that contain a drying material, usually alumina or silica or activated carbon. One contains the desiccant that removes moisture from the airflow from the compressor. The other one regenerates the desiccant already used after the pressure has fallen under atmospheric conditions. The flow reversal cycle is automatic and the regeneration is performed first on one column and then on the other. This type of dryer has the advantage that it works up to -70 degrees and it can be used even at outdoor temperatures in the winter season. You should be aware that the desiccant materials must be periodically replaced. In conclusion, whatever you need, the first thing is to rely on qualified personnel who can advise you on which type of compressor or dryer to use to be sure that you have chosen a technical solution that is durable and ensures you good performance over time. An undersized appliance will save you money at first, but it will certainly cause you problems and higher costs in the medium-long term.